Hello, everyone. Thank you for tuning in to this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, bringing you conversations that go into different aspects of what it means to run cloud native infrastructure and applications on it. And I'm excited today to be talking to actually two gentlemen from the startup named Akamas, aka MAS. I have with me Luca Forni, who's the CEO, and Stefano Doni, who's the CTO of Akamas. Welcome, guys. It's great to have you here. Thanks for joining.
Thank you, Twain. Thank you. It's great to be here.
Right. Great. So, as we just get started, wanted to get to know you a bit. So, if you guys could share briefly your background leading up to Akamas, there'll be some good context into where you're coming from.
Yeah, so myself and Stefano started together in a consulting service company called Moviri at the time, almost 20 years ago, doing consulting service about everything related to performance engineering, data center optimization, capacity planning, stress testing, monitoring the new observability wave, and so on. So doing working in the same area of the Akamas market area, but with a different point of view. That was a consulting services approach for especially for large enterprise, so all around the world. So we started doing this kind of job, but we discovered that there was a gap in the market related to how to implement optimization after a lot of different very cool tools like the observability one, the capacity planning one, the stress testing one, discovered some bottlenecks or waste in terms of resources that at the end is waste of money in your application, in your service, in your data center, in your cloud environment, and so on. So all these kind of tools moved in terms of their evolution path as technology in being able, also using AI, but to exactly highlights when there's an issue, highlights where you can improve your system. But then it's up to you as an expert to analyze all this kind of SIGA metrics, sometimes hundreds of charts or data collected from a tool. And then it's up to you to understand how to implement the fix or how to proactively tune your system. There's three different area where you can do that. Usually that is, of course, hardware optimization. So sometimes it's just a system that is under provisioned, so you need to add more hardware. Sometimes it's a matter of code. So there's a code tuning. But there were a third area that was not so highlighted by tools. Also in terms of skills, there's a big gap on the market. It was the configuration, so parameter settings. So every kind of pieces in the stack, so part of the technology that is serving your system, sometimes comes with hundreds of different parameter settings. And it's very hard, it's very complex to tune in a balanced way all of them. Because when you start touching something in a specific part of your system, the result is that you have an impact somewhere else. And talking about hundreds of parameters for every single piece of the stack results in billion, trillion of different combination. So it's like the butterfly effect. No? So what they immediately understood is that we need something that supports us. It's just not observability, it's not only capacity planning, not stress testing, something more that drive autonomously the optimization and tuning part of the overall optimization part of the process, of the flow. And that's why we result at the end say, okay, no one is doing something like that. So 5 years ago, we released the first version of Akamas to the market. And that was mainly an AI that drive in an autonomous way this concept of optimization in a super fast way and tackling the complexity behind all these this set of parameters behind the hood.
Interesting. How long ago did you guys start?
So we
When was it?
started releasing the software on the market officially in 2021. If the company was created in 2019, but we spent a couple of years researching and tried to identify the best AI that can fit this kind of need. And by the chance, we at the end the result was create a new AI. So everything that was on the market at that time was not sufficient, was good enough to solve this to the software. So we start from scratch, creating a set of algorithms, a new approach. The results in 5 patents that we got, thanks to the fact that no one was at that time able to create something like that. So we immediately got patents from both the European office and US office. So that's great.
Right. Yeah, when you mentioned AI, that's something more recently in the past 2 years that AI has actually gotten a lot of focus. But seems like you guys started from even before that. So you guys were using AI concepts even before ChatGPT came on the scene and made AI popular. Could you talk a bit about that? Were you calling it ML at that time? What was it like when you started?
Stefano, I'll let you answer.
Yeah, yeah, great question, Trey. So in fact, what we have a lot of LLMs and generative AI today that is kind of course, very having a very high impact on a lot of industries. For example, one of the biggest use cases, of course, software development, but actually LLMs are not that good from an optimization perspective. So our approach, even before actually the rise of LLMs, was to have a more like a reinforcement learning approach. So it's a more machine learning approach where you have real optimization algorithms, because at the end of the day, if you think about all those parameters, it's actually an optimization problem. So you need to find the best values for all the parameters in order to match a goal that the customer can actually, the user can define. So in one sense, it's similar in that you give a goal, like for example, I want to reduce cost, or I want to improve performance, or I want to improve reliability, or I want a mix of those goals. And then basically the machine learning tries to recommend and do that automatically as well, to apply the best settings for this specific goal. So in one sense, kind of resemble the today kind of approach with LLM, that you ask something, then the system goes and do its own work behind the scene and comes up with the answer. We kind of applied the same approach a couple of years before, but we are much more, the big difference that is a much more kind of deterministic approach, in that we use our really the strategy is that, of course, using algorithms and AI, because they can crank much more data with respect to kind of the human brain, but also couple that basically algorithm approach with deep technology knowledge. So as we are going to talk about, so for example, the technology stack has hundreds of parameters, but you need specifically to know them. So it's not just that you throw hundreds of parameters at an LLM or any other AI system and it comes up with the best possible answer. It doesn't work that way. So many people have tried that. So we have this combination of using AI and deep spatial knowledge about the technology stack in order to come up with the best possible recommendation from the user in the short amount of time possible, because that's also the other key outcomes that our customer require.
Interesting. Would you say then it's more quantitative analysis than qualitative? You're dealing with more numbers at a large scale than, unstructured data and words and all of that. Would you say so?
Yeah, definitely. It's also a combination, in fact, as we are going to show also in the demo. So the core algorithms, it's a kind of optimizing, so finding the best values for the key parameters that we know for the specific technology stack. But we also have added over time other capabilities, like, for example, helping engineers, for example, software development team that are not expert about the technology, helping them find the problems that they have in the technology stack. So I'm over provision here. I'm risking reliability issues there on the JVM, on the HPA, etc. So that's kind of the core algorithms that, but over time we kind of added other capabilities to actually increase, actually solve other problems, adjacent problems in this space. So it's really a combination of different set of techniques that we use to, at the end of the day, make the optimization simpler, more democratic for all the teams, not just the expert, but really even software development teams, SREs that actually have these kind of problems. Highlight the problems first of all, and then help them fix manually with recommendation. We are kind of more human in the loop approach, or even automatically in order to kind of get rid of all the possible effort that you have in this process and realize the benefits.
All right, that's great. So Luca, when you said you want to optimize for the stack, I was just wondering, what do you mean by stack? And if you could explain to us what kind of stack you have in mind. Is this very primarily Kubernetes cloud native kind of stack, or is it doesn't matter where you run, whether you use Kubernetes or not, any stack you can optimize? Well, define stack for us.
Yeah, so I would say now we can work in two different approach. We started with having this concept of full stack clear in mind, because coming from this kind of manual tuning consulting service experience, we found out that being able to really tune in a super balanced way every single pieces of the puzzle, I mean database system, Linux environment, plus caching system, the network itself, front end, whatever is included, the runtime, so the code runtime, I mean the JVM or Node.js or the CLR for the .NET application. So you need to have every single part that is perfectly working in harmony. So it's a matter of what we call mechanical sympathy, recalling 60, the year 1960, there was a Jackie Stewart, a pilot that was that for tune their F1 car. So there was a perfect meaning also for us. So every single part of your environment that can be like a car need to work perfectly balanced. So the wheel, the engine, the way the driver drive the car. So and it's exactly the same. And every part of the stack comes with parameters. So that's where Akamas works. Of course, there are also other specific stack that usually are more common, let me say, or now it's the new wave, like having Kubernetes and in a cloud environment that works with specific like Java environment or .NET or whatever you have in place as runtime and code development strategy. But so in a way, we work at full stack level, trying to balance the configuration of all the stack. But of course, require involving several teams in the company. So also in a matter of organization can be challenging, especially large, working with large enterprise spread all around the world. You can have several teams working in several country. So that's also one of the main challenge that customer can have adopting at the full stack level the Akamas approach. So also we introduced a way to simplify the approach for customers that are on Kubernetes. So with this new module that we are introducing, we work in a lightweight mode specifically for Kubernetes, where we can immediately give you the recommendation about the whole Kubernetes environment plus what is contained in the Kubernetes environment. But this allows us to be very effective and fast in customers that are using Kubernetes, but give customers that are not using Kubernetes, not in cloud, so traditional legacy system, work using Akamas that requires the interconnection between all the layers, thanks to the fact that Akamas is able to tune everything else. So in this way, we can work in getting both of the benefits for the customer that is using or not Kubernetes.
Well, excellent example there about F1. And what comes to mind when you think of F1 and performance optimization is it's actually more about what parts can you actually remove without affecting performance. How much can you reduce? That really becomes the focus. And in F1 and in these competitive racing competitions, that is the focus. And so yeah, I'm just wondering, can you give us some examples like that of some of the top areas that can be easily removed during optimization? In other words, which are the low-hanging fruit? Where do you get started if you want to optimize performance? Which parts of your stack do you need to touch first? Give us some more details on that.
Stefano.
I can take this one. Yes. So if we think about Kubernetes, by the way, we just released our top 10 pitfalls on Kubernetes, which kind of exactly touches on this point. So when we talk about optimizing Kubernetes, we like to say to the customer that you really need to look at the full stack. So mainly you have two big components. You have the infrastructure and you have the application that are running on top. So the easiest, typically the easiest way that customer basically is struggling with is on the application part. So I would say the single most important issue is request and limits of the pods, right? So how do we properly set request and limits? So that's where typically either we see lots of over provisioning or some under provision that may lead to performance issues specifically. But then one of the things that gets often overlooked, especially as we are performance, is that within your container, you actually have an application that is running. And if you think about all the modern languages, the top 4 modern languages, like, for example, Java, Node.js, .NET, or even Golang, they are powered by our runtime. So most commonly, the JVM is the most well-known one. And basically, no one is actually looking at inside the JVM, but the JVM is actually a very big engineering marvel that runs within your pod. It has hundreds of parameters, and it tries to kind of auto-tune itself based on the pod size, but lots of those choices may introduce either performance issues, so slow down due to the famous, for example, garbage collection problems, or actually wastage due to poor settings of the heap size. So actually, we like to look at all those layers from the application side. I would say the runtime, the pod size. Then on top, you will add the third layer, which is, of course, the auto-scaling. Again, that's another big change and big issues. Like, for example, you can add HPA. Kubernetes is great in that it provides out of the box those capabilities that were very hard to achieve before, but still you need to tune, you need to do performance tests, you need to try and different metrics, different thresholds, because if autoscaling is not working properly, either you will miss your SLOs, so the pods will be too slow to start, and you will have these big spikes on response time, your user won't be happy, or on the other side, again, you will throw more resources at the problem. So actually, that's kind of typical tendency from developer teams, of course, and you actually will waste money. So that's why we always like, even in the product, it's not a FinOps tool, but we always position ourselves to, and even explain, educate the customer that you have really performance, reliability, and cost, and you need to consider the three of them at the same time, because otherwise, of course, you can, if you just try to reduce costs, of course, you may significantly impact your availability, which is typically a higher priority, right? So we have Kubernetes to provide a business service, not just for the sake of it. So it's very important to understand, if I remove, I don't know, one part of my F1 car, what would be the impact on performance? Sometimes I have no impact. Sometimes I even can go faster. So we have example where reducing, for example, the heap size, the JVM works better, and I can even change the garbage collector. I can even go faster. So that's also the very interesting insight that comes up out of the optimization sometimes that are really surprising. And traditionally, performance engineer or SREs may not be able to kind of look at those configurations that AI is able to find.
Yeah, absolutely. Wow, some great points there. Those 3 pillars of optimizing. There's performance, reliability, and costs, and none of them can be compromised. Another aspect that comes up when you think of balancing these 3 is, it's not like a one-time thing. It's not like, okay, tomorrow I'm going to optimize my stack and then I can leave it untouched for the next 1 year. It's continuous, right? Because businesses change, new priorities come up, new features get released, there's new regulations to keep up with, and so things keep changing all the time. So then it's a repeated, continuous thing. Sometimes it's small optimizations, sometimes it's major optimizations that are needed. That are more like just reconfiguring major parts of the system. Talk to us about this idea of optimizing being a continuous thing, and what that means for organizations, and how they can actually do continuous optimization the right way without getting bogged down, but actually doing optimization continually.
Yeah, it's a matter of company culture, I would say. So it's exactly when also we start dealing with a customer, the first thing that we try to understand is the maturity that they have in their process of collecting data, so the observability, whatever is in place, plus everything related to tuning and optimization that uses a manual approach, so like the FinOps or the capacity planning or the stress testing and quality assurance before going in production approach that they have. Uh, Optimization in this way, thanks to the fact that we have a powerful tool with an AI that is able in a super fast way to continuously adapt and change the system. Exactly. Going back to the F1 cars, when something changes during a race, you are ahead or are after one other car, the airflow change, and you should adapt the shape of the car. That was an interesting idea of one, that there was the self-shaping cars that adapted the shape. So that if you are familiar, the DRS is exactly that way. So you can change the shape of the car, moving some parts in order to be faster just in the straight way, but you cannot do that when there's a turn, because otherwise you go and crash your cars. And that's exactly the same approach that we need to have something that's continuously change the shape of your IT environment. That means, the Kubernetes settings, the JVM settings, application settings also, in order to have everything perfectly adaptive for the workload, the real-time workload. So what is needed in real time, because your user, your business is requiring you minutes per minute a different way to react. So think about the peak load, like the Black Friday or something like that. So you need to be very reactive on that, or proactive, be ready to adapt your system to the surge of load. Or when the system is low in terms of load, you need to be very efficient and not waste money. So this approach require exactly what we said. So it's perfect the consideration you made, a continuous approach. But to have a continuous approach in terms of optimization requires that every single silo of your organization works with this mindset. So you cannot tune an application and leave alone and hope that everything will work, because your application is continually changing due to new release. You set or implement a new fix, security, sometimes security fix in some part of the technology, and that change, of course, the load on your system. So the way that the application or the operating system is stressing your CPU, your memory, every part of your technology. So you need to adapt every single parameter you have in your full stack. So at the end, what we are suggesting right now to our customer is to set up like an optimization governance, or someone that is responsible for overseeing all the optimization activity across the whole enterprise organization. That is not a matter of taking care about stress testing plus capacity planning plus observability. It makes no sense. They have their own goal, their own technology, own approach. But someone that is able to say, if the capacity planning team identify somehow in some way that something should need to be done in order to get the benefits, the same for FinOps, the same for observability, you need to have someone that is responsible for it and have the authority to force changes in your environment in order to get this kind of load. Because what we see sometimes is that some of these practice process are in place in the company, but the recommendations, the tuning activity, the fixing activity, even if they are manual, so sometimes slow, sometimes not so effective, but they are good sometimes, are not implemented, because who is responsible for implementing this kind of activity has no time, do not trust the results of someone else. So sometimes the results is that they remain on papers or inside the tools. So what we strongly suggest is using automation, create a super cool workflow that runs very smart from the collecting the data, analyzing the data, suggesting things, and applying immediately them. Of course, this requires that everything is super safe. Is not part of, let me say, not good. If you do not have in place a strong stress testing strategy, you need to be careful about applying the same recommendation for pre-production environment to the production one. But if you are able to create a good cycle of that, and you can have an AI that govern, oversee everything, and for you recommend, calculate, collect data, analyze the data coming from this kind of data sources, and then implement autonomously that using your release management strategy, whatever you have in place, this is the key. The issue we see is that still there's no an optimization manager or head of optimization in a company. But what we are seeing, and I think in the future maybe there are some organization area that can be responsible for that. Can be SRE team, can be operations team, can be performance engineering team. So according to how your organization is governed, can be different. So this head can be put in different area, but definitely having this kind of role, this kind of capability is a key to get what you see results that are tremendous. That means 60%, 70%, sometimes we go 90% of cloud cost saving. That is tremendous if you think, especially when a company is spending million or dozens or hundreds of millions in infrastructure or cloud cost.
All right, 90% cost savings. That's crazy. Yeah. Really interesting. We've kind of touched on a lot of different points, and we've, spoke about the background and the context behind all of this optimizing that you've described. Wondering if we could get into the demo now and see in action what this optimization actually looks like. If Stefano could, just show us a walkthrough of your dashboard and some of the key parts of the Akamas platform, that would be great.
All right, so actually this is the new module that we were talking about, so Akamas Insight, that is specifically tailored for Kubernetes. So we see a lot of adoption of Kubernetes, of course, but we see a lot of teams struggling, as we said, not just about cost, but also reliability. So the first thing that actually Insight does is actually collecting all the data from your Kubernetes environments and actually present you this dashboard, which actually shows you pretty much the whole dimensions that typically people care about. So you have efficiency, which means basically resources and cost. So you have the current estimated cost, the estimated savings that you can realize, and also the kind of impact on the resources. You have reliability as well, as we say. So very quickly, we show the amount of workloads, for example, in cluster and nodes that have reliability issues. So again, we try to always balance the two actually side of the coin, right? We also have, by the way, a compliance indication in that many SREs team, for example, want to understand or platform team if all the application teams are actually leveraging best practices in order to realize performant and reliable services. So we also have those kind of basically checks built into the platform, so that again, if you are a very distributed team, you can keep track of compliance issues in terms of configuration in the workloads. So taking, for example, efficiency as an example, so what we also do is that, okay, we estimate the whole benefit, the benefits by applying all the Insight recommendation, but we also show a background, breakdown of all the layers that you need to tune in order to achieve this kind of benefits. Remember that we always believe that attacking the full stack is the best way to realize the savings. And sometimes this means, of course, working on the workloads and on the runtime, like the JVM, for example, but other times you may have inefficiency in the cluster itself. So again, the workloads run on the cluster, and the cluster actually powers the workload. So it's important to tune them basically together, and not just in a way start with a cluster autoscaling, for example, and then forgetting about the workload. So we try to kind of show the customer that you have these two parts that needs to be tuned. Then we also have, of course, we go a little bit deeper. So that's the high-level summary. We go deeper in the cluster. So, for example, I take one cluster here. I have the estimated cost that I can and benefits that I can achieve. If I go inside, as I say, the most important basically challenges people are facing on Kubernetes is about the workloads. So, for example, you can see here that right away, without any effort, we clearly basically show the issues, or as we say, the optimization opportunities in this cluster. So again, we have efficiency opportunities, like, for example, the utilization is much lower than requests and limits. So CPU is basically over provision, the same for memory, etc. So opportunities that you have in your environments without any expertise, we quickly surface that for saving resources and costs. But also what is extremely important, for example, for SREs, is understanding if due to misconfiguration, I have some reliability issues that may risk that may impact my service. So, for example, sometimes people forget to set the requests and limits, for example, or the utilization, I have throttling, I have utilization very close to my thresholds or above the request. So those are kind of best practices that we baked into the tool based on our experience, so that, again, with also due to organizational things, there are many development teams that use Kubernetes. They are not Kubernetes experts, right? So we try to kind of surface the most important insight, as that's why we also named the product in this way, for them to actually quickly understand the problem and basically fix it. Then I can go into the workload details. For example, say that I don't know, I'm a FinOps person. I need to understand what's the biggest saving that I have in terms of money for each single workload. So, for example, I can see that's the biggest one. I want to show the second one, which is more interesting because it shows another capability that we have. So I go into a specific workloads where I can save money. So I have this summary that shows basically usage, request, and limits for the pod. But also remember, we go inside the pod. So we can actually look at, in this case, the JVM that is powering this application. So we can understand what's the heap size, what's the heap used with respect to the memory. So all those considerations are important for actually improving the efficiency and the reliability of the application. So if you look at this case, what we found out is that, of course, you have CPU usage much lower than limits, as you can see here. So it's very low with respect to requests and limits. So we can clearly basically right-size the pod. But most importantly, we also detect that the JVM heap size usage is very low. So I have assigned too much of a memory to the JVM. That's a common problem in Java applications. So if you look at here, after presenting the problem, we actually have a very easy to apply recommendation that teams can go and apply in production if they kind of want to realize the savings. So if you look at the recommendation, what we do here is, of course, we adjust the requests and limits, but what is interesting is what we do with memory. So we recognize that we have a JVM inside. So in order to save money, we not simply reduce the requests and limits for the memory, but we also downsize the JVM. So what we do is, first of all, we make sure the application is as efficient as possible, and then we can shrink the memory of the pod, for example. Otherwise, if I leave my JVM to be, I don't know, gig and gig of heap size, I cannot really save resources, right? If I just simply kind of adapt to the container size. And here I can estimate the benefits, actually, that people can achieve by applying the recommendations. So in terms of money, but in terms of, I will save six core on this simple microservice, and also we save this amount of memory. Teams then can actually very quickly apply this recommendation. We have this kind of manual way. If team want to kind of get started, it's typically the preferred approach, so they can go and simply issue a kubectl command to patch the deployment and also adjust the JVM configuration, or you can actually configure for these changes to be automated in your environment. So that's a typical kind of scenario and problem that we see from a kind of cost reduction perspective. What we also have as a unique differentiator is this view about application runtimes. So thanks to the fact that we go inside the pod, we can look at all the JVMs that are running in your, if you are a Java shop, for example, it's important to make sure that all the JVMs are configured properly. Otherwise, as we say, we risk reliability and performance issues. So we have a specific view across all the JVMs in your environment, and you can actually see recommendation and optimization opportunities for your runtime as well. So you can see that I have, I don't know, 60 JVM, 75 JVMs where actually the heap usage is very low. So those are over provisioned. But also have JVMs that where basically the pod memory limit is very close to the heap size. So I'm at risk of having an out of memory keys on Kubernetes. So again, we highlight those issues. So for example, if I kind of show you an example of this problem, so memory limits are too low, I can go in, I can select one of the workload that has this problem, which is kind of very interesting because actually you can see I have a heap size of 1.8 gig with a limit of 2.2, basically 2 gig. So it's too close. So the JVM will actually trigger very easy and out of memory errors. And I have here this problem that is clearly identified and explained. So again, this is a reliability issue. So I'm not saving money here, but instead I'm actually adding more CPU and more memory to make this application more reliable. While at the same time, as you can see here, I'm not simply increasing the memory limit, but I'm also shrinking the heap size. So Insight always tries to give you the most actually reliable configuration, but at the same time, if it can also shrink the JVM, so balance the cost and performance and efficiency. So it's not that I'm simply bumping up the memory limits because these are too close. I'm also shrinking the heap size because I realized that the application is not really using that. So that is important to realize, to kind of bring home the message that Insight basically very quickly gathers all the data, provides you the problem so that people can understand that they have problem and it can fix, recommend very, very easy change to do that are very safe. So even trusting the recommendation is an issue. So while being full stack, we are much more safer with respect to all the other tools on the market that just then don't look at the JVM, basically at the runtime. By the way, JVM is the most common runtime that we see, but we are adding, for example, Node.js as well. So for Node.js developer, that is going to be very important. Last piece, which is key, is that how can one user kind of leverage Insight? What is the other differentiator is that we have with respect to all the other tools is that you don't need to install really anything on your clusters. So what we do instead is a much more easy to start and lighter approach. You most likely already have an observability tool for your Kubernetes environment, right? So the idea is that if you use the entrance of Datadog, just actually give us basically the token and the access to your Datadog observability tenant, basically, and Insight will start basically collecting all the data from all the technology stack, all the layers in the stack. So again, that's another differentiator because sometimes customers are hesitant to kind of install yet another agent on the cluster for many reasons, including security. So it's a much quicker and easier way also to evaluate and to assess, for example, what's the status of efficiency and reliability of your clusters.
Right.
Yeah, and if I may add just one thing, Trey, this is just a part of the whole platform. So it's the new model that we are just releasing. So we prefer to focus on that just because it's like a cool preview that maybe can be useful also for your audience. But you can think that we have the same approach for all the other technology stack. Especially when you work in a pre-production environment. So the capability to RAI to drive a stress test in your application, reusing your current stress testing tool and your stress testing strategy that you already have in place as a customer. So do not need to install yet another stress test tool, yet another agent, record the scripts and so on. So whatever you already has in place, RAI is able to reuse them, drive them to create a new simulation of your workload, and then optimize things in the same way also on a database system or everything else that is not, so also a physical hardware system, so Linux environment or bare metal, or if you have Kubernetes on bare metal, it's not just for cloud and Kubernetes. This model that Stefano showed is specifically designed for Kubernetes to make things very easier. So no install, no anything. Just give me your API key of your observability tools, and in a matter of minutes or hours, your system is tuned, or you have everything to tune that if you don't want to apply an automatic tuning approach. But as mentioned, you need to have what we force the customer to have a very strong culture about performance engineering, autonomous optimization in a continuous mode. That's the key.
Right. All right. Great. Yeah, fascinating demo. I like how it showed exactly the number of CPUs you can reduce and the exact amount of memory you can reduce. And also that it's not just reduce, but even there are certain parts where you need to increase memory so you don't run out. So it's balanced that way. And that you can get specific recommendations when you click in so that it's not just top line numbers, but you're getting exact uh, changes that you can actually go and make to see those results. So yeah, well put together and a good demo there. Uh, you know, I want to ask about just as someone gets started with this, what's the first month like? What can they expect when they start using a solution like this? What are some of the first steps? How do they get started? And what kind of results can they expect to see in the early days?
Yes, depends of course of the approach. So if you want to work with this new module that is the lightweight version just for Kubernetes, you can get results really immediately. As soon as you have your observability tool already in place that is collecting data, it's a matter of connecting. I can start importing the data that are important. So it's just a matter. So we don't know. Of course, we don't want to replicate the full storage system that your observability data has in place, because it makes no sense at all. But just picking up everything that is needed according to the issue that the AI identify. So collecting the metrics, calculating them, and give you results. And it's something that can be really got in a matter of hours or few days. If you wanted to go to full, also outside Kubernetes, outside the full environment that you have, sometimes, all customers do not have a strong Kubernetes flowing process. So maybe just 5% is on Kubernetes. Everything is still in a legacy traditional data center approach, or clouds, public cloud, but without Kubernetes. So you need to have an observability tool in place, of course, or you want to work in pre-production, especially financial services institute don't want to work directly in production, of course. So need to have everything in place. If you already have everything in place, it's still a matter of a couple of days, 3 days, 1 week to get the results, and usually get their ROI. So there's a lot of customers that got the full ROI of the full license just during the few days of the POC. Because during the POC, even if the POC is just focused on a very small subset on their whole environment, the results in terms of saving we got is so high that justify the purchase of the license. But of course, if you do not have a stress test strategy in place, or your observability tools need to be tuned, let me say, because lack some coverage in the system that you need to optimize, or in terms of metrics that you are collecting, what is required is to set this kind of metrics. So it's more up on the strategy of the customer. If they have an internal team, we can provide some professional services directly or through partner. That's what we usually prefer, to have some consulting services activity provided by partners that support you in creating your stress testing strategy or observability, or sometimes the automation strategy. And then Akamas, as soon as it is in place, is a matter of really few hours or few days to have everything in place. Usually the first part, because sometimes stress test is not good enough. Sometimes the observability, so a customer just choose a good tool but still lacks sometimes skills in implementing it. So coming from 20 years of experience in doing that, we can also suggest how to improve that. But currently we prefer to avoid that. So prefer to work with a partner strategy for that, or train the customer to do that by ourselves. So also we provide training in order to have everything in place in the right way and leverage the capability of Akamas to be full autonomous, press play, and let the system work for you.
All right, all right. What's an average a percentage that you tell your, people who are considering using Akamas that they can save or reduce in terms of costs or improve in terms of performance? What are some numbers that you kind of put out as a ballpark? And I know that
Yeah.
it varies in different organizations. I'm just trying to get an idea.
As you say, it's very different. It's also according to how is large the large enterprise will deal it. Of course,
Yeah.
what I can share with you is two numbers that are very impressive for me. The first one I already mentioned is a customer that said 91% of cloud cost. It was tremendous, of course, in a matter of 15 days, something like that. We have a customer that is a large enterprise in the United States that just saved 13%. There was an improvement in performance of their application. But they calculated that just a 13% in improvement of the response time of the web page, because it's a large e-commerce, the results was more than $800K per year in terms of more business.
Sorry,
So
more than how much?
I'm sorry?
Sorry, more than how much is
$800,000 in improvement of the business, thanks to the fact that we reduced the response time of this shop. This was a microservices that were responsible for the calculation of the cart. So it just was one very single and small microservice, but it's one of the largest e-commerce in the world. So this kind of savings, they usually with manual tuning activity that spans across months, they were able to save 1%, 2%, not more. Thanks to Akamas, in a matter of 15 days, they were able to save 13%. That's tremendous for them. But according to us, it was a very small. So I say, this POC was not so good, because we usually have something like 50%, 70% in improvement. But they say, no, for us it's tremendous. So this kind of improvement is results in something like 1 million per year in more revenues or in cost savings, as a matter of if you focus on performance or you focus on cost. So that's why I say it's very hard to say ballpark numbers, because we span across the whole ecosystem of what we got. But if you want to give an average, often we are more on 50-70% of improvement. That's tremendous, of course, but it's just a matter of applying in a super vast way something that you can do manual, but it's too complex. So that's the balance between having an AI and automation in place.
Got it. All right. We're winding down. So we had quite an interesting conversation. We touched on so many points about, how, optimizing shouldn't just be about cost. Three pillars Stefano mentioned, and that all of them are important. And we spoke about how optimization should be continuous. It's not a one-time thing. And Stefanos also gave us a demo where he showed us your product in action. And we spoke about when we get to implementation, what are some of the things to keep in mind, how to start, what kind of results to expect. And finally, you gave us even these percentage numbers to expect. Quite a fascinating conversation here on optimizing for not just cost, but performance and reliability as well. As we wind down, we close this conversation. Is there one thing that you'd like to repeat, one thing as a key takeaway from this conversation that you'd like to leave listeners and viewers with before we close?
Yeah, what I would say is that it's part of what we're seeing on the market, and maybe all the customer and all the technology vendor need to I think, to take in mind, is that the fact that we are seeing a convergence between several different areas that are around the optimization world. So I think observability, that usually is a reactive approach, so giving charts and highlights alarms or something like that. FinOps strategy, that more on cost optimization. The capacity planning, that it's a long-term achievement, but is bit of them. And the stress testing, so everything that is related to pre-production environment in order to go in production in a safe way with a strong strong consciousness about how a system is performing. In this area, all the common part is the optimization, as you think. Now what we are seeing is that the convergence of this kind of optimization is one unique process. Still not one unique tool, but of course one unique process. So we, as Akamas, we are trying to fill the gap about having a unique tool that is collecting and try to connecting the dots between all one. So the key takeaway I would say is that what we are expecting in the future is this whole organization needs to start thinking about create some point in the org to try to govern all this kind of. Otherwise, every single part, even if it is very precious and get a tremendous ROI, work in a siloed way. And at the end, you don't get the full results, the full benefits of have a strong observability strategy in place, also in terms of tool, process, and team, a strong capacity planning, and so on. So automation plus AI is able to give you and boost the benefits that every single team and tools and practice inside the company can usually give us if think about a silo one.
Okay. Wow. That was a fascinating conversation. Thanks for joining us today, Luca and Stefano. It was wonderful having you on the podcast. Do come back again whenever you release anything that you'd like to talk about, anything big in your product that you're excited about. We'd love to have you back.
Thank you.
Awesome.
Thank you, Dwayne.
Awesome.
It was great.
All right.
Bye.
Glad to be
Ciao.
here.
Bye.
Bye-bye.
Ciao.
And thanks to all of our listeners and viewers for tuning in. We hope you enjoyed this conversation around optimization of your cloud resources. And do get in touch with the team. So it's Akamas, that's akamas.io. That's the website. Go and check out what they're doing and their approach to optimizing for the cloud. And we hope you'll join us on the next episode. See you on that one. Bye-bye.